Chemistry lessons with Dave.
So basically our next topic is how to solve stoichiometry problems using BCA tables. And I just set up a pretty simplified BCA table right here. I'll show you how to use it in a bit. So first I'll present the problem that I'll be showing as the example. So we have this reaction, Fe2O3 plus 2Al. So this goes to 2Fe plus Al2O3. So the question is, what masses of iron 3 oxide, and aluminum, so these two, must be used to produce 15 grams of iron? So basically, what they're asking is 15 grams of this. How much of these two are required to make 15 grams of that? So basically, using a BCA table, so before we use x because we don't know it right now. This is x, also x, and then because these two will be used up in the reaction, we subtract it. That would be 0 and 0 now because we aren't using any excess. So basically, you have 15 grams for this. So first, most important thing is that BCA tables involve moles. We have F2Fe, so Fe, 15 grams of that. That would be 15 divided by 55.85. That would give you 0.269 moles. So we add that. Because in the beginning, you didn't have any of this, you add 0.269. That's what you get, 0.269 moles. 0.269 moles. Now, so in order to convert this back to this, so since this is 1-to-1, so this is 2Al, this is 2Fe, so it's a 1-to-1 ratio. So this will be minus 0.269. You look at this is 2-to-1. Therefore, you have to divide it by 2. So it's 1/2 x, which in this case we established is 0.269. So now we can, this BCA table is set up. It really helps a lot now. Because basically, you're given the moles now. All you have to do is multiply that to the molar masses of this and to this. So basically, you have 1/2 times, you have 0.5 times 0.269. That gives you 0.1345. And now basically the molar mass of Fe2 is just 55.85 times 2 plus 48. So it gives you 159.7 times 0.155. That's the grams for this. And you add that to the molar, you add that to this, multiplied by the molar mass of Al. So Al is 26.98 times 0.269. That gives you plus 7.2 grams. So when this is all multiplied together, added to this, you get the answer. However, in this case, we're not asking for the total, so you don't need to do it. So for now, this is 7.2 grams, or 7.3, depending on how you rounded. And then this multiplied together, 159.7 times 0.135. That gives you 21.6 grams. So you have 21.6 grams of Fe2O3 and 7.3 grams of Al. That's how much you need to get 15 grams of Fe. So now the second part of the question is asking how much Al2 is produced in grams when these react. So again, it's just basically the reverse. You know this is 0.1345. So this is a 1-to-1 ratio. So it'd simply be 0.1345 multiplied by the molar mass of this. So Al is 26.98 multiplied 26.98 multiplied by 2, and then add that to the 3 times 16, 48. So 26.98 times 2 plus 48. So 0.135, which is the moles, times the molar mass of 101.96. And because of that, you get points, multiply that by 5, you would get 13.
Please, no. I laugh too much.
1 grams. So that's how much would be produced for AO2O3 out of this reaction. So now, that's the first question. It's a pretty long question. So just look. So basically, that's what it's produced. If you want to see this, you can just go back to the video. Stop. So now, for our second problem, it's just simply KCl03. So you have KCl plus P4 goes to P4O10 plus Now, basically, you're given 52.9 grams of potassium chloride. This potassium chloride, you were given 52.9 grams.
Stop.
And it says that red phosphorus is in excess. In this reactant, you don't need to take that into consideration because there's more of this and more of this. You don't need to worry about the limiting reactants. So now you have 52.9 grams. You need to find the moles for that. So 52.9 divided by KClO3. So KClO3 would simply be, okay, again, find the molar mass. KCl, that's 39 plus 35 plus 48. So over 122. 52.9 over 122. That gives you 0.434 moles.
So the first step you want to do is you want to count.
Basically, before you have 0.434 moles. When you subtract that 0.434 moles,
There's 3 elements.
afterwards
There's
it's
nitrogen,
0.
oxygen, and
This
hydrogen.
don't really matter
On
because
the
it's
left
excess,
side
so you don't need to take this into
there's
consideration.
1
But if it's
nitrogen.
not excess, you
There's
would.
3 hydrogen.
So now since it's
and
minus 0.439, it's a 1-to-1 ratio. You add 0.439 moles here.
I wrote NH3
Because you're trying to find how much of this is produced.
Yeah, I know, but
So then it's because of that, you add it, it'd be 0.439 moles afterwards. So before you have this change, you subtract, you add, and afterwards you would have 0 on this side because it's reactants, it's all used up. On this side, it's 0.439. So now simply all you have to do now is multiply 0.439 by the molar mass of P4O10. So the molar mass of P4O10, so P is 30.97 times 4. The oxygen, okay, so oxygen is just 16 times 10, so it's 30.97
So the first step you want to do is you want to count how many
times 4
each element there are in
plus
this
160.
So on the left side there is 1 nitrogen,
times
3 hydrogen,
284.
and 2 oxygens. On the right side there's also 1 nitrogen,
That in turn will give you
2
124
hydrogens, and then there will
grams.
be 2 oxygens.
So that would be the
So
answer
what
to
you
the
want
problem.
to do is you want to get these
124
numbers,
grams
say.
of P4O10 will be produced.
What you want to do first is